Okay, so this week the lesson is all on chapter 18, and last week in class we covered displacement. We talked a little bit about velocity and average velocity, and we're going to move on this week to talk about total distance traveled and acceleration. It's kind of all mixed together in my opinion, and it's important to see the connections between everything. So we went over this in class. I'm not going to go over it again. Feel free to pause the video or check out the notes. You talked in groups about what is the difference between distance and displacement. What is the difference between speed and velocity. And we're going to keep going over all of this stuff. So basically we learned that when the displacement is positive, we can say that point P is to the right of the origin. And when the displacement is negative, we can say that point P is to the left of the origin. We looked at a motion diagram about this point, and here's our function right there from 0 to 7 seconds. We looked at how we graphed it, and these important points show us where our point is changing directions from going right to left. So it's going to the right, then to the left, and then to the right again. So on our motion diagram, it moved to the right, to the left, and then to the right again. And we talked about how the derivative of the position function is the velocity function. And the velocity function, if the velocity is negative, it's telling you, when you find the derivative, you can find the velocity function. We did that. Algebraically, you can find the zeros of your velocity function, and the zeros of the velocity function are going to tell you where your point is not moving left or right. So they're stationary points. And we got t equals 5 and t equals 2. Those are these same values. And when I graph my velocity function, you can look at my picture right here. You can see that this velocity function does have zeros at t equals 2 and t equals 5. Okay. We said we could find the average velocity between 0 and 7 by maybe we didn't say that. I thought we did. Okay, but we found by the slope. So we're going to move on. Here is the average velocity. So it's the change in position, or the change in displacement over change in time. And then the instantaneous velocity function is the derivative of your position function. Okay, so then we said, well, what does the integral of the velocity function tell you? And we can calculate the integral on our calculator. Find the integral, where the lower limit is 0 and the upper limit is 7. And we got 77. Same thing if we did it by hand. And that's what we did here in class, and we got 77. And what does that number mean? That is the displacement. It's not the total distance traveled. So then the question became, how do we find the total distance traveled? Well, we don't want to count that negative area. We don't want to count the area. We don't want to subtract off the parts where it's moving to the left. So we said, well, maybe if we graph the function, but we graph the absolute value of the function. And I'm actually going to go back here and not graph that. So now our function looks like this. And now if we find the integral, what's the upper limit? 7. Now you can see that we get a total of 131 meters, which is much more if we're counting the total distance traveled, because we want to count this distance plus this distance plus this distance. And so now we have this ability to find the total distance traveled. So ignore this part, that part's wrong. The change in displacement is when you find the integral of your velocity function at the two different times. The total distance traveled would be if you did the absolute value. Now, if you're going to do the absolute value part by hand, for this particular one, we said we had to break it up into 3 different integrals. The first one was from 0 to 2, and then 2 to 5, and then 5 to 7. The first integral is fine of v of t. The third integral is fine v of t. But in order to flip that middle part up, we have to make it negative. And then we could do it by hand. I don't know why I have an extra parentheses there. Okay, so if you're given the graph of a velocity function, and we're not even given the function, so this is just the graph, just to understand the concepts here. It says the velocity, v is meters per second, of a particle moving along a line is shown in the figure below. Find the particle's displacement and distance traveled over the interval 0 to 11. So we said that the displacement is going to be the integral. So we can find the displacement by finding all of these areas. So this right here, the first one right here is a trapezoid. So I use the trapezoid formula 1/2 times b1 plus b2. Those are the bases. So the first base is 2. The second base is 6. We're counting by 2s. So is the first base 2? Yes, 3, 2, 5. Yep. And then times the height, and the height is 3. So the area, this area here, I got to be 12. I found the area of the second one by making a triangle. Base times height divided by 2, or 1/2 times base times height. I got an area of 4.5. And then finally, this last one is also a triangle. Did the same thing. Base times height divided by 2, and I got 3. So to find displacement, we're going to do 12 minus 4.5 plus 3, and we get 10.5. So the area below the x-axis is actually counting as negative, and that's for displacement. To find the total distance traveled, we're just going to add all the areas together, and we get 19.5. All right, moving on. Average acceleration. You can use this formula. So you're finding the velocity at 2 different times. Oops, looks like I forgot a parentheses. And then dividing it by the difference in the times. And then the acceleration function would be the derivative of the velocity function or the second derivative of the position function. All right, so let's look at this example. A particle moves along a line, a horizontal line. The particle's displacement in meters from the origin O at time t seconds is given by s of t equals 4 minus 2 sine of 2t. A says find the particle's velocity and acceleration at any time. So for that, they're looking for the velocity function and the acceleration function. So the velocity function is the derivative of this position function. When you take the derivative, don't forget the chain rule. So the derivative of 4 is 0. The derivative of negative 2 sine would be negative 2 cosine of 2t. And then you have to multiply it by the derivative of the angle. The derivative of 2t is 2. So that's where I got negative 4 cosine 2t. Then the acceleration function would be the derivative of the velocity function. So the derivative of negative 4 cosine of 2t. You'd get negative, or you get positive, actually, 4 cosine, and then you have to remember to multiply it by the derivative of 2t, which is 2, That's where I got positive 8 sine 2t. Find the particle's initial displacement, initial velocity, and initial acceleration. So now I'm just substituting in 0 in for my displacement function, velocity function, acceleration function. So when I plug in 0, the sine of 0 is 0, so I'm just left with 4. When I plug in 0, the cosine of 0 is 1. I'm left with negative 4. And when I substitute in 0 for the acceleration, I get 0. The label on velocity is meters per second, and the label on acceleration is meters per second squared. What are you doing? I'm doing a video. Okay. All right, letter C. Find when the particle is at rest. Find when it's moving to the right, and find when it's moving to the left on the time 0 to pi. So to find when the particle's at rest, we're going to set our velocity function equal to 0. So I did that. Divide by negative 4. When is cosine equal to 0? Cosine is equal to 0 at pi over 2 or at 3 pi over 2. So I'm going to set 2t equal to pi over 2 and 2t equal to 3 pi over 2. And then when I solve, I get t equals pi over 4 and t equals 3 pi over 4. Those are the times when the particle is at rest. From here, I'm going to make a sign diagram. I put 0 on pi over 4, 3 pi over 4, and pi. And I want to test points into the velocity function to test for positive or negative. I got negative between 0 and pi over 4, telling me that the particle is moving to the left. I got positive between pi over 4 and 3 pi over 4, telling me that the particle is moving to the right. And then again, negative. So I wrote left at pi over 4, or 0 to pi over 4 and 3 pi over 4 to pi, and to the right at pi over 4 to 3 pi over 4. Letter D says, find the displacement of the particle after pi seconds. So the displacement is going to be the integral of the velocity function. So I'm going to take the integral of the velocity function, and maybe you want to do a u substitution here. Whatever helps you find the integral, but the integral of negative cosine is negative sine. And then just remembering that we have a function inside of a function. So I divided by 2. So I got negative 2 sine of 2t. I substitute in and I get 0. Now this is going to be different than the total distance traveled. The total distance traveled, I would need to break it up into 3 different integrals. If it's moving to the left, I need to make it negative, so it changes the sign. When I do that, I got 8. Thanks for watching.